Now I want to take a few minutes to talk about linear equations in three variables. A linear equation in three variables represents a plane in space. The plane x plus 2y minus 2z equals 6 is shown to the right. And so we think of this plane that just kind of extends on forever. Like think of it, if you look at your ceiling, think of that ceiling just kind of goes on forever in all directions. A solution to a system of equations in three variables is a common point of the intersection of all the planes in the system. Now we want to identify inconsistent systems. A system of equations may have no solution. Such a system is said to be inconsistent. An inconsistent system will reduce to a contradiction. For a system of two linear equations with two variables, the lines would parallel. For a system of three linear equations with three variables, the planes will not all intersect at the same points. So you could have two planes that are parallel and a third plane cuts them at different points. Or maybe two of the three overlap but never all three. Or maybe all three are parallel. Or maybe two planes are the same, the third one's parallel. In either case, this would all have no solution. So if we look at an example like that, and where we can see how it happens algebraically, you go through and you do your row operations. And when you get down here at the bottom, you end up getting zeros here on the left side of the bar and 56 or some other non-zero number to the right. And this would tell us that 0 equals 56, which means that's impossible. So if I get a bottom row that's all zeros except for the last number is not 0, then we'd say our system would have no solution. And so the solution would be the empty set here. You can also have a dependent system. A system of equations may have an infinite number of solutions. Such a system is said to be dependent. A dependent system will reduce to an identity. For a system of two linear equations, two variables, the lines will be the same. For a system of three linear equations, three variables, the planes will intersect in a line or all be the same plane. So here's an example of the three planes intersecting in a line. And here's an example where all three planes are the same. So let's see how this would work. So if we're asked to solve this system equation, the first thing we need to do is get it in standard form. So we would subtract x from both sides. Now, some people might want to go ahead and clear out that decimal, and you can do that by multiplying by 100. Now, I'll leave that up to you. So your equation in standard form would end up these two. We'll go ahead and write the augmented matrix. And here they go ahead and they interchange row number 1 and number 2. And I need to first make this a positive one, so they multiply row 1 by negative 1. Next, we're going to multiply row 1 number by the opposite number of this 25. So that'd be by negative 25 to get 0 in the low left corner. And so I'm going to multiply row number 1 by negative 25 and add it to row number 2. Again, when I do this, I like to use lowercase r's here instead of capital R's. It just makes it easier. And then when you do that, notice you get zeros all the way across. If you get zeros all the way across, that means there's an infinite number of solutions, since every point in the line is a solution. We express this by solving the equation for x. So our solution would be the set of all points 3y plus 4 comma y. So it's kind of a weird way, but you're saying y is arbitrary. I can make up any number, and this is the way I can generate all those possible points. Alright, so let's take a look at number 11. And we'll look at 11, 12, and 13 together. And this is a multiple choice question. So, kind of fun, huh? we want to be able to solve the system, and it's a multiple choice, so we have to figure out which one's the correct answer. So in this first one, if we're looking at this, the second row here means 0 equals 4. That's a contradiction. That's not possible. So my answer is going to be no solution. So my answer would be C. The second one, I got zeros all the way across. So this last equation means 0 equals 0. This is an identity. So what I need to do is I need to write that first equation as x plus 2y equals a negative 9. I need to solve for x. So I'm going to subtract 2y from both sides. Now I'm going to write my numbers as the set of all points with x coordinate of negative 9 minus 2y, comma, y coordinate y. So that would be answer choice D. Now this last one, this would mean y equals 0. So this is a consistent system with one solution. So if I multiply this by negative 4, if I multiply row number 2 by negative 4 and add it to row number 1, that's going to give me a matrix 1, 0, negative 5, 0, 1, 0. That's going to tell me x is negative 5. So my answer here is going to be A. It's going to be the point negative 5, comma 0. All right, so solve the system of linear equation using the Gaussian or Gauss-Jordan elimination. If this system has infinite many solutions, give the solution with y arbitrary. When they say that, that means they want us to write the solution this way. All right, so we're going to take a look at this first equation. And on this first equation, we have 2x plus 2y equals negative 6. Second one, we have 3x minus 2y equals 7. It's going to be easier to work with that first row as is. So first step, I'm just going to go ahead and write the matrix. It's already in standard form. And remember, the first step, in the top left corner, I need to get 1. So I'm going to take row 1, and I'm going to divide it by 2. So when I do that, that becomes a 1, 2, and a negative 3. I'll leave row number 2 alone for right now. So I'm just going to copy it back down. My next step, I just need to get a 0 down here where there's 3 at. So step 2 is to multiply row number 1 by the opposite of 3, would be negative 3, and add it to row 2. So notationally, it's going to be row 2 equals negative 3 row 1 plus row 2. And let me do it off to the side here on my scratch paper. So I'm going to multiply this by negative 3. I'm going to write down row number 2 underneath it, which is 3, negative 2, 7. I'm going to go ahead and add it, and that's going to give me my new row number 2. 0, negative 8, 16. So the first row is still the same. That just comes down. But now I'm going to replace that second row by 0, -8, and 16. Okay, so next, moving counterclockwise, I need to get a 1 here where that -8 is. So I'm just going to take row 2 and divide it by -8. So I'm going to copy down row 1. Row 2, I'm going to get 0, 1, -2. And now my last step is I want to get a 0 here where this 2 is. So I'm going to multiply row 2 by the opposite of this number and add it to row 1. So notationally, it's row 1 equals -2 row 2 plus row 1. And again, I'm just going to do it off my scratch paper here. -2 row 2 would be 0, -2, 4. Row 1 would be 1, 2, -3. Add these, oops, should be row number 1. Add these together, that'd be 1, 0, 1. Now I'm just going to read off the solutions. Here this would be x is 1. This would be y is -2. So my solution here is going to be 1, -2. So let's try this next one. They're in standard form, so let's go ahead and write down our matrix. 0.25, 0.75, 1, 6, 18, 5. First step, I want to get 1 in the upper left corner, so let's just divide everything in the first row by 0.25. So that's going to give us 1, 3, and should be 4. And let me do that in red, my bad. And then I'm just going to copy down the second row. Next, I want to multiply row number 1 by the opposite of this 6 and add to row number 2. So again, I'll do it off to the side here. -6 row 1. That would be a -6, -18, -24. Sorry, kind of went off the side there. Row 2, just copy down there 6, 18, and 5. Add them together, it gives me my new row 2, which would be 0, 0, and -19. So this would be 1, 3, 4, 0, 0, -19. And right here, we can't go any further because I didn't get a 1 there. This means that 0 equals -19, which means no solution. All right. Let's try number 16. So number 16, we have 6x minus 3y equals 9, and negative 2x plus y equals negative 3. So we go ahead and write our matrix. And we want to get an entry of 1 in that first row and first column. So I'm just going to divide everything in row number 1 by 6. That'll give me 1, negative 0.5, and 1.5. Row number 2 would be negative 2, 1, and negative 3. Just bring that down. Next, I want to get a 0 here. So I'm going to multiply row 1 by the opposite of negative 2, which would be a positive 2. So my row 2 is going to be 2 times row 1 plus row 2. Again, Alex uses capital R's here. I like to use smaller cases because this just helps remind me that I'm working with these rows here to generate the new row 2 down here. So I'm going to take, this would be a negative 2 row 1, which would be 2, negative 1, 3. My row 2 is negative 2, 1, and negative 3. When I add these folks together, I'm going to get 0 across the board. Well, this is 0 equals 0. That's an identity. That's an infinite number of solutions. And so this is where it gets a little complicated. We have to write this in terms of y. So what I need to do is I need to write down that first equation. That'd be x minus 0.5y equals 1.5. I need to go ahead and solve for x. So I'm going to add 0.5y to both sides. So my solution set would be the set of all points in the form of 1.5 plus 0.5y comma y. So that would be my answer.